Hi there. When you're adding a whole series of numbers, rearranging them and gathering up the bits that make 10 makes sense. I'll just rearrange these numbers. So now that I've rearranged them, I've got a 7 and a 3 that make a 10, an 8 and a 2 that make a 10, and a 5. So I've really got a 10 plus a 10 plus a 5. So that's 25. And that was a lot easier because when you're adding, it doesn't matter which order you add them in. You still get the same answer, so you can rearrange them and then add them up and you'll get the same answer. Now there's something very similar that you can do with multiplying. Imagine you had to multiply all these numbers together. That's going to be quite difficult, but if you rearrange them and you spot the ones that multiply together to make 10, you can make it easier. Because what I have here is 7 times 3 times 5 times 2. And both of those bits were quite easy. 7 times 3 and 5 times 2 was quite easy. So if I multiply it in that order, getting 21 times 10, 210, I've made the question a lot easier because I spotted there was a 5 in there and a 2 in there, and they multiply together to make 10. There's something very similar with 25s and 4s, which I'll show you in a second. So if I was to do 3 times 25, get an answer, and then do times 4, that would be quite difficult. But if I do 25 times 4 first, and then multiply it by 3, that's much easier. So once you've memorised that the 25 and the 4 multiply together to make hundreds, you can look out for them. Here's a nice collection of numbers to multiply together if you rearrange them and multiply them in the right order. So you'd have the 25 times the 4, and then times the 5 times the 2. And I hope you're spotting that this one's 100 and that one's 10. So that's 100 times 10. The answer is 1000. So by spotting that the 25 and the 4 went together, you made it easier. Now sometimes 25s and 5s and 2s and things can be hidden in amongst other numbers. 15 times 4. You can't really see a 5 times 2 in there, but there is one, it's just sort of hiding, because the 15 is a 3 times 5 and the 4 is a 2 times 2. So hidden in there was a 5 times 2. So it's really like 3 times 2 times 5 times 2, which is really like 6 times 10, 60. So sometimes, even though you can't see a 5 and a 2, if there's numbers that are factors of other numbers, you can sort of expand them out and multiply it all out to find the bits that will make it easier. Here we've got 75 times 4, and it would be great if that was 25 times 4, because then it would be 100. But if you know that the 75 is 3 times 25, then you can sort of manage to get a 25 times 4 in there. So that's really 3 times 100. So I'm often talking about number bonds for adding and how much easier it is to add if you can find the bits that make 10 and add up all those tens. Well, it's much easier to multiply if you can spot the bits that make tens or hundreds and sort of extract them out and see what you're left with. Thanks for watching. Bye.